Hello there, Algebra 2 students. As you can see at the top of my notebook page, the title here, what this video is going to review is it is going to review properties of exponents. So we're going to have a couple properties we're going to run through, and I'm going to do an example of each of those properties. So to get started over here on the left, you'll notice our first property says multiplying exponents. If you happen to be multiplying exponents, so for example in red here, if I have a base b raised to the power of m times that same base b raised to a different power n, then that is going to equal that same base. So the base does not change, but now it will be to the power of m plus n. So if you are multiplying two expressions, two bases that are the same with different exponents, you are going to add those two exponents. So over on the right of that kind of general rule that we have there in red, I'm going to do two examples. So the first example says simplify 3x to the fifth y to the fourth times 4x squared y. So if we go ahead and we start here by simplifying, we're going to start with our coefficients. So our coefficients, we have a 3 and a 4. So if I were to go ahead and take 3 times 4, I have 12. So I'm going to have 12 times, and then if we go ahead and we focus here on our x's, you'll notice here we have x to the fifth and we have x squared. So if we go ahead and we multiply those, following our multiplying exponents property, we're going to add our exponents. So 5 plus 2, that's going to give me x to the seventh. Then I'm going to go ahead and I'm going to take my y's. So I'm going to say, okay, using my y's here, I have y to the fourth, and then I have times a y. Remember, if there is no exponent, that's like a y there to the first. So if we add our exponents, 4 plus 1, that gives me y to the fifth. So my final answer, simplifying this expression, is 12x to the seventh times y to the fifth. So there's example 1 of that first property. Our second example says simplify 2x to the 1/2 times 3x to the 3/4. So again, same kind of idea. If we start with our coefficients, I'm going to say, well, look, 2 times 3, that gives me 6. And then here I'm going to need to take x to the 1/2 times x to the 3/4. So if I take that, I'm going to have x to the 1/2 plus 3/4 power. If we go ahead and we simplify that, so if I kind of change colors here and come down, we have here 1/2 plus 3/4. And we need to add those. Well, remembering what we know about fractions, we know if we add fractions, we have to have common denominators. So if we take that first fraction and multiply the top and the bottom by 2, that's going to give me 2/4 plus 3/4, which gives me 5/4. So this means that my expression up here simplifies to 6x to the 5/4 power. So there is my final answer. So that's our first property, multiplying exponents. If we move on to our second property of exponents says power to a power. So if we have a power raised to a power, so for instance, if I have a quantity with a base b again, raised to a power of m, and then that whole expression is raised to the power of n. So anytime you have a power to a power, so in this case we have a power of, or an exponent of m, raised to another power or exponent of n, then that's going to give me my base b, so the base does not change now to the power of m times n. So again, I'm going to do a couple examples over here. If we start with the first one, it says simplify x to the sixth and then quantity cubed. So again, if we have a power to a power following our rule over here, that's going to give me 6 times 3, which gives me x to the 18th power. So there is my final answer to simplify that first expression. If we go ahead and we look at our second example, it says simplify, and we have x to the 2/3, then to the 1/4 power. So again, following my property over here, I'd say, okay, well look, this is x to the 2/3 times 1/4. So if I go ahead and I simplify my fractions there, knowing what we know about fractions, we know when we multiply fractions, so in this case 2/3 times 1/4, we can just multiply our numerators, multiply our denominators, and this is going to give me 2 over 12. We can simplify 2/12 and say, well look, that simplifies to 1/6. So that means that our final answer here is x to the 1/6 power. So there is our second property of exponents. So if we go ahead and move along following these two properties, our third property is what we call power of a quantity. So power of a quantity would be, again, for example, if I had here maybe the number 3 times some base to the power of m, and then we raise that whole quantity to the power of n. This is where I see most students make a mistake, is that if that whole quantity is to the power of n, I got to both raise my coefficient of 3 to the power of n, and then I got to take my base b, which is already to the power of m, so we kind of have a power to a power, that last property. So we'll have b to the m times n power. So that, again, is our kind of general rule, our property. So we're going to do two examples over here to the right. So if I start with this first example, you'll notice it says simplify the quantity 2x to the fourth y, all raised to the quantity of 3. So if I simplify this, that means I'm going to have to take my coefficient of 2, raise it to the third. Then I have x to the fourth, and I got to raise it to the third. So if I have a power to a power, I'm going to multiply it. I'm going to say 4 times 3 is 12. Then notice here I have a y, and then I need to raise that to the third. Remember, if there's no exponent, there's kind of like a little 1 there. So again, if we take a power to a power and we multiply, we're going to get y to the third. We're almost there. We've almost simplified it. Last step is we could say, well, 2 to the third, 2 times 2 times 2. That gives us 8. So our final answer will be 8x to the 12th, y to the third. So there's my final answer, or my final simplified expression for that first example. Following the same thing, if we move on to example 2, it says simplify 16x to the 6th, all raised to the 1/2 power. So again, we're going to start here with my coefficient. I'm going to say, well, look, this needs to be 16 to the 1/2 power. And then if we have x to the 6th, the 1/2, following our power to the power property, 6 times a half gives me x to the 3rd power. The only thing we're left here to simplify is we need to simplify, well, what is 16 to the 1/2 power? We did this in class before we kind of went on our extended break, and we noticed, well, look, if I raise anything to the 1/2 power, that is the exact same as taking the square root of it. So if I have 16 to the 1/2 power, that's the same as the square root of 16. And hopefully remember, well, look, the square root of 16 is 4. So then our final answer for this second kind of example problem would be 4x to the 3rd. So there is our second example. So there are the first three properties. If we go ahead and move on to our fourth property deals with negative exponents. So if we have an exponent that happens to be negative, and generally we want to keep our exponents positive. So for instance, if we have here some base b raised to the negative m power, well, that is the same as negative exponents just move things from the numerator to the denominator, or the denominator up to the numerator. So if I have b to the negative m, that's saying, well, look, we need to take b and we're going to raise it to the positive n, but now it's moved into the denominator. So that equals 1 over our base b to the power of n. So again, we're going to do two examples over here kind of to the right. The first one says simplify 3 to the negative second. So if we simplify this, since it's a negative power, that's going to move it to the denominator. So we're going to have 3 to the positive second in the denominator. And then to simplify that, we could say, well, look, 3 squared, that is 9. So our final answer, or our final simplification here, is just 1/9. So that's our first example. Second example says simplify a cubed times b to the negative second divided by c to the negative fourth. So if we simplify this, since we have a cubed, it's a positive exponent, it's just going to stay in the numerator. So I'm going to leave it in the numerator, or on top. This b here to the negative second power, since this is to the negative second, I'm going to need to move that down to the denominator. So if I move that down to the denominator, we're going to end up here with a b squared down in the denominator. And then if I look at the current denominator, I'm going to say, well, look, my current denominator is c to the negative fourth. So that c to the negative fourth, since it's a negative exponent, we're going to move that up to the numerator. So that's going to tell us that we have a cubed times c to the fourth. Now that all of my exponents are positive, there's nothing I can simplify there. That is my final answer. So that is our fourth property of exponents. So we've gone ahead and we've done 4 properties of simplifying or covering our simplifying of exponents. If we move on to the fifth property is dividing exponents. So, for example, if we have a base b here raised to the power of m divided by that same base b raised to the power of n. Just like if we review or we look back to our very, very first property, when we happen to be multiplying here, we said, well, look, that means we're going to add our exponents. Here in this property, if we happen to be dividing, then we're going to say, okay, well then instead of adding our exponents, we're going to subtract. So this is going to be base b minus, base b to the power of m minus n power. So that is our property, that is our rule. So we're going to go ahead and we're going to apply that rule over here to our 2 examples. So if I start with my first example, it says simplify 8x squared divided by 4x to the 6th. So if I start with my coefficients, my numbers, I'm going to say, well, 8 divided by 4, that's going to give me here 2. So I can say, well, look, there's a 2. If I go ahead and I take here my x's, I'm going to say, well, look, I have an x squared divided by an x to the 6th. Well, that's going to give me 2 minus 6, which equals negative 4. Because that is a negative number, that means that I'm going to have x to the 4th in the denominator. So that is my final answer for that first example. All right. So if we go ahead and we try the second example, it says simplify 5x to the 5/3 power divided by 15x to the 1/3 power. Again, if I go ahead and I start with my coefficients, I could say, well, look, 5 divided by 15. If we simplify that fraction, a number that divides both 5 and 15 would be 5, and that would leave us here with 1/3. If now we look at our kind of our variables, our exponents, we have x to the 5/3 over x to the 1/3. So if we go ahead and we take 5/3 minus 1/3, since we have common denominators, we can go ahead and we can subtract and we can say, okay, that's x to the 4/3. Since that's a positive number, my x to the 4/3 is going to go in the numerator. And I could write that like what I have there, or another one, so I'll go ahead and I'll put here, or is you could write this as 1/3 x to the 4/3 power. I would accept either of these as proper or correct answers to this example. So there's our fifth property of exponents. If we go ahead and move on to the sixth property is what if we have a 0 exponent? This one's probably the easiest, probably the one that maybe we remember the most, is that if I have here our base b raised to the 0 power, no matter what that base is, if you raise anything to the 0 power, this is always going to equal 1. All right. So we're going to just do one example with this. So the first and only example with this property says simplify 2x to the 4th, y to the negative 3rd, and then that whole expression is raised to the 0 over x to the 6th. So if we simplify this, you'll notice that because in the numerator, you'll notice everything here is all raised to the 0 power. That means that everything in the numerator just equals 1. And then our denominator is still just x to the 6th. And that's it. That is all we can simplify that to. So my final answer for this would just be 1 over x to the 6th. So almost there. We have one property left. So our very last property is what we call converting rational exponents and radicals. So if we think about this word rational really just means, okay, well, what if we had a fraction as our exponent? right? So for example, if I had here a base b raised to the power of m divided by n power. So if we have a base b to the m divided by n power, so we have a fraction in the exponent. What that's saying is it's saying, well, look, the denominator, that's telling us the nth root. So we're used to seeing square roots, but it doesn't have to be a square root. It would be the nth root. And then underneath that root is going to be our base b raised to the numerator of our fractional exponent there, m. So maybe kind of using a couple different colors here, you'll notice that the numerator stays the power underneath the root, and then the denominator of our kind of fractional exponent power, that is going to tell us kind of what our root is. Are we taking a square root, a cube root, a fourth root? And kind of in our next video, we'll go through and we'll talk about how do we evaluate roots like that. But for right now, we just want to be able to rewrite our expressions. So if I start with this first example, it says simplify and then 8 to the 2/3 power. So if I start here, I'd say, okay, well then what this is telling me, my denominator is 3, so this would be the cube root of, and now underneath this, we're going to have 8 raised to the 2nd power, because that was the numerator of my fractional exponent. And we can simplify this from here, right? Most of us know 8 squared. We could say, okay, well, 8 times 8, that gives us 64. So now we have the cube root of 64. And if we wanted to simplify this, we're going to ask ourselves, okay, well, what number raised to the 3rd power would equal 64? So what number times itself 3 times is going to equal 64? So if I think about maybe here and I'm brainstorming and I'd say, okay, well, look, 2 to the 3rd power. So 2 times 2 times 2, that gives me 8. So that's not going to equal 64. I could say, well, look, what about 3 to the 3rd power? So a 3 times a 3 times a 3. Well, that's going to give me 27. I could say, okay, how about 4 to the 3rd? Well, a 4 times a 4 times a 4. Well, 4 times 4 is 16. 16 times another 4, that gives me 64. So by simplifying this, I could say, well, look, this is like the cube root of 4 to the 3rd power. And then now if I have here the cube root of 4 cubed, the cube root and the cube, kind of for lack of a better terms, they undo each other. So we could say, well, look, the cube root of 4 cubed is really just 4. So this whole thing of 8 to the 2/3 power just simplifies to 4. All right. So that's our first example. Second example, using this idea of converting between rational exponents and radicals, we're going to kind of go the other way. So it says simplify the square root of x. So if you don't see a little number kind of inside the check mark or the root there, we're going to assume that there's like a little itty bitty 2 inside there. So this is the square root of x times the cube root or the 3rd root of x. So if we take this idea and we think about, well, look, let's write that as a fractional exponent. So I'm going to say, okay, well, underneath the square root, this is like an x to the 1st. So if I think about writing my fractional exponent, I'm going to say, well, look, this is like x. Since my fraction exponent here, the exponent underneath my root is a 1, so that's going to be a 1. And then my root, I'm taking the square root, so then that's going to be a 2. So my fractional exponent that we have here is x to the 1/2 power. And then I can say times. And then again, I'm going to say if I have the cube root or 3rd root of x, and since it's just x there, we're going to pretend there's like a little 1 kind of exponent there. And I can say, okay, well, look, this is going to simplify to x to the 1/3 power. And then we can go ahead and we can use our properties from earlier, kind of our very first property that we can say, well, look, if we have x to the 1/2 times x to the 1/3, we could say, well, look, that simplifies to x to the 1/2 plus 1/3. And then we just need to simplify that. So if we go ahead and we say, well, look, we need to figure out what is 1/2 plus 1/3, we can go ahead and we can get common denominators. If my two denominators are 2 and 3, hopefully most of us would come up with the fact that our common denominator here is 6. So if I multiply the first fraction on the top and the bottom by a 3, that's going to give me 3/6 plus, if I multiply the second fraction on the top and the bottom by a 2, that's going to give me 2/6. And then if I add those 3/6 plus 2/6 gives me 5/6. That tells me that my final answer here is x to the 5/6 power. Really quick, we could rewrite that x to the 5/6. We could say, well, what would that be given like as a root? Well, if we rewrite that as a root, we'd say since the denominator of my fractional exponent's a 6, this would be like the 6th root of now x to the 5th power. So either of these mean the exact same thing. They're just two different ways of writing it. One is with a rational exponent. One is like writing with a root. So with that, we've gone ahead and we've reviewed all properties of exponents. And that is it for our notes.